Have you ever noticed how things tend to get messier over time? Your bedroom, for example, might start the week perfectly tidy, with clothes neatly folded and everything in its place. But as the days go by, clothes end up scattered, books pile up on the desk, and a general sense of disorder takes over. This natural tendency toward disorder is what scientists call entropy. Entropy is a fundamental concept in physics that describes the randomness or disorder of a system. The more disordered something is, the higher its entropy. Think of it like this: a perfectly ordered deck of cards has low entropy because the cards are arranged in a specific sequence. But shuffle that deck, and the entropy increases because the cards are now in a more random, less predictable order. Entropy is all around us, governing everything from the melting of ice to the expansion of the universe. It's a powerful force that shapes the world we live in, and understanding it is key to unlocking the secrets of energy and thermodynamics. Imagine dropping a single drop of ink into a glass of water. At first, the ink remains concentrated in a small area, but slowly and steadily, it begins to spread throughout the water until the entire glass takes on a uniform color. This spontaneous spreading is a classic example of entropy in action. The ink molecules, initially confined to a small space, naturally want to spread out and occupy a larger volume. This is because there are far more ways for the ink molecules to be dispersed throughout the water than there are ways for them to remain clumped together. Entropy always increases in an isolated system. This means that in any process where energy is not exchanged with the surroundings, the total entropy of the system will always increase over time. Think of it like a game of cosmic roulette. The universe is constantly shuffling the deck, and the odds are always in favor of greater disorder. While entropy might seem like a rather abstract concept, it's actually a measurable quantity in physics. Scientists use the unit joules per Kelvin, JK, to quantify entropy, which represents the amount of energy dispersal per unit of temperature. One of the key properties of entropy is that it's a state function. This means that the entropy of a system depends only on its current state, not on how it got there. Consider two identical glasses of water, one prepared by melting ice cubes, and the other by simply pouring water from a pitcher. Although the water in each glass might have taken a different path to reach its final state, the entropy of the water in both glasses will be the same. This property makes entropy an incredibly useful tool for analyzing thermodynamic processes. Section 4, the second law of thermodynamics, entropy's reign. The concept of entropy is inextricably linked to the laws of thermodynamics, which govern the flow of energy in the universe. The second law of thermodynamics, in particular, states that the total entropy of an isolated system can never decrease over time. This law has profound implications for our understanding of the universe. It means that the universe is constantly moving towards a state of greater disorder, and that this process is irreversible. Think of a broken egg. It's easy to imagine the egg shattering into a messy splatter on the floor, but it's impossible to reverse the process and put the egg back together. This is because the shattered egg represents a state of higher entropy than the intact egg, and the second law of thermodynamics dictates that entropy can never decrease in an isolated system. Section 5. Everyday entropy from coffee to the universe. The concept of entropy might seem abstract, but its influence can be seen everywhere in our daily lives. Take a cup of hot coffee, for example. As the coffee cools down, it releases heat energy into the surrounding air. This heat energy spreads out, increasing the entropy of the room. Another example is the aging process. As we age, our bodies gradually become more disordered, with cells and tissues breaking down over time. This increase in entropy is an inevitable part of life, reflecting the universe's relentless march toward greater disorder. Even the universe itself is not immune to the effects of entropy. As the universe continues to expand, stars will eventually burn out, galaxies will drift apart, and the universe will slowly approach a state of maximum entropy, often referred to as heat death. Section 6. Entropy's importance, unlocking the secrets of energy. Understanding entropy is essential for comprehending the world around us. It helps us to explain why certain processes occur spontaneously while others do not, and it provides insights into the limitations of energy conversion. For example, Entropy dictates that it's impossible to create a perfectly efficient engine that converts 100% of heat energy into work. There will always be some energy lost as heat, increasing the entropy of the surroundings. By studying entropy, scientists and engineers can develop more efficient technologies, from power plants to refrigeration systems. Moreover, understanding entropy is crucial for tackling global challenges such as climate change, which is driven by the increasing entropy of the Earth's atmosphere.